How you doing, everyone? Greetings and welcome to today's episode of 8 Bits in the Basement. So this is a kind of an exciting episode for me because today what we're going to be looking at is a PCB design that I made myself. This is my very first PCB design and we're going to see, does it work and does it fit into the enclosure it's supposed to fit into? That's pretty much what we're doing today. Now before we start, I just want to give a huge thanks to the sponsor of this episode, PCBWay. They're the ones who made these boards for me, and thanks to them I've got a box with 5 of these PCBs I've designed right here beside me. Now PCBWay are world leaders in PCB manufacture, and you can get 5 boards created by them for you for just $5. We'll talk a little bit more about that in a little while. But just let me tell you what happened, the reason that I had to design my own PCBs. You see, I was writing a little game for the Thomson MO5. It's a rare enough French micro, so it's not all that popular and there's not all that many parts spare available for it. And when I wanted to check my game on real hardware, it was running fairly okay on the emulator, I came down here and set up my MO5 and it was all raring to go, and I found that a load of keys on the keyboard weren't working. And it came down to the age-old problem of 40-plus-year-old mylar starting to fail. So what I really needed to do was to try and replace that mylar. But you know what, before we go any further, let me just show you what mylar is and I'll explain to you what it does. So what I've got here on my bench is my Thomson MO5, or what's left of it at least. This here is the system that was giving me hassle with the keyboard, and because of my little repair, now has a keyboard that doesn't work at all. So what's basically wrong with it is, if we open it up here, you'll see that this keyboard assembly part here is kind of a sandwich. We've got a black piece of plastic, which is normally held in with 8 screws, pushing this mylar part, which is like plastic sheets, against this rubber keyboard. So what we're kind of interested in, because what I have broken badly and what needs to be replaced, is this whole mylar section. And what it basically is are 3 sheets of plastic. You'll notice that there are 2 of them that have a kind of conductive paint printed onto them, and it makes up a kind of a circuit here going out to an edge connector. And there is a second one going out to a second edge connector, which is pretty much the same type of setup as that. And between the 2 then we've got a clear plastic sheet with a couple of holes pierced in it. And basically what happens is, when the 2 of these are put together, these are connected into the MO5's main board. And when you press one of the rubber keys, it causes the mylar to press against the others. So you've got the 2 printed circuit ends kind of pressing between each other. And what it causes to happen is a bridge to be formed between a line on this connector and a line on this connector, which feeds back into a chip on this board and registers a key press. Now, my little repair that I tried to do, I kind of ended up removing an awful lot of the conductive paint off this. So this thing is pretty much no good anymore. Okay, so as you gathered there, while I was trying to fix it initially, I made it even worse. And now I've got a keyboard that doesn't work at all on my MO5. So the only solution that I really had to me was to find another mylar. So I had a look on the internet, and to my dismay, I found that mylar replacements just aren't available for the MO5. The system just isn't popular enough. So they're not really there to be had like they are for the Spectrum. So I remembered back that when I was building my Leningrad, the ZX Spectrum 48K clone, I needed a keyboard for that. And looking around, I found a PCB keyboard mylar replacement for the ZX Spectrum. And what it was a very, very thin PCB with a whole heap of micro switches soldered onto it. And then there was 2 cables that connected into the Spectrum mainboard itself. And what you would do is, once you had it kind of installed in the Spectrum, you would put the dead flesh Spectrum rubber keyboardy thing on top of it. And every time you would press one of those rubber keys, you would get a key press registered. So I figured this would be a good way maybe to replace my Thomson MO5 keyboard because they use pretty much the same kind of keyboard layout, more, well, not layout, but the same system. So that's what I decided to do. But as a very first project, this was going to be a little bit challenging because, okay, a keyboard matrix isn't all that hard as far as a circuit goes. It's just points connected to points. But the footprint of the PCB was going to have to be pretty much bang on precise, size-wise, and also with hole placements. So this here is the mylar that I want to turn into a PCB. So what I needed to do was I needed to take accurate measurements of absolutely everything I could think of on this actual mylar. So what I did first, in order not to confuse myself, is I marked the two main layers, top and bottom. And that way I could differentiate between the two easily. Then what I did was I quite simply measured it. So I got the height and I got the length. I marked those down onto a piece of paper. And then there are just kind of 5 rows of keys running across. We've got the spacebar on the bottom and 4 other rows. So what I did was, working from the top, I took the center point of each row and I marked down the measurements for each row onto a piece of paper. Now, for the horizontal button placement or key placement, that was a little more complicated. There was more measurements to do because the buttons aren't always in a straight line. So I needed to take each row's measurements individually. So I took the center points of each and every one and marked those down onto a piece of paper as well. And this here is the information that I recorded. So I've got my dimensions of 95 by 276, and then I've got my key placement on the verticals. So the five measurements working from the top to the middles, which are 16, 32, 48, 64, and 80. And then working on the horizontal for each of those rows, I've got the center points of each key working right the way down to the bottom row, well, which is like the 5th row, which is the space bar here. So once I had done that, I took my hole measurements. So there are a number of small holes, which I did in exactly the same way. I took them on the vertical and then on the horizontals. And there's also a number of large holes here. And I took the center points for those. So I noted all of that information as well. And that was all the information that I needed in order to transfer all of this to a PCB. Okay, so with the measurements taken, what I needed to do was convert all of that information into a digital form that I could send to PCBWay to have them create or make up those PCB boards for me. So asking around, it turns out that KiCad is probably one of the best applications you can use for PCB design if you're someone like me who really didn't know what the heck they were doing. So just to give you a quick taste of KiCad, pretty much this here is what you get when you start it up. You've got a number of different menu options, but all we're going to really look at today is the schematic editor and the PCB editor. So first we'll click on the schematic editor, and that's because we want to lay out a schematic of the circuit design we want to make a PCB for, so that KiCad knows pretty much exactly what it is we want to do. So we start off by laying out our components. So we click over here in Add Symbol. And that gives us a list of thousands upon thousands of different symbols or components, really, like ICs, capacitors, resistors, switches, connectors, all that kind of stuff that's already there available to us in KiCad that we can choose and lay out our schematic design with. So you'll notice here for each one you pick, you've got kind of 2 pieces of information. Up here on top, you've got your symbol or your schematic a representation of the IC or component that you've chosen. So here we've got a kind of a square or a rectangle kind of representing a chip, and there's a number of pins out of it, all numbered and all labeled as to what they are. And down here on the bottom we've got our footprint for this very IC, which is how it will appear, the placement for it will appear in the PCB editor, which is kind of the next step that will be taken after we've laid out our schematic. And the footprint is assigned to the symbol. And you're not really stuck with what's there. You can assign any footprint you wish to any symbol you wish. But what we're going to do is, I'm going to show you pretty much the switch symbol that I used in order to create my keyboard here. So I laid out loads of these, but you'll see that it's got a name, SW1, and here's our symbol. It's just a very simple kind of momentary on-off switch with two connectors on it, 1 and 2. And if I double click on it, you'll see information about that particular symbol. You see it's given a reference name, it's got a value, but one of the things it doesn't have, and it needs to be imported into the PCB editor, is a footprint. So luckily we can assign our own footprint if we so wish. So just clicking here, it brings up kind of the footprints database more or less, and there's thousands of those there as well. So what I've done is I've selected an ALPS type switch with stem, which are the very type of switches I used to design my keyboard PCB. So we will validate that, and now we've got that actual footprint assigned to our symbol here. So what I'm going to do next is I'm going to copy this and I'm going to paste it a number of times so that I can show you how we can lay out a schematic and import it into the PCB editor. So here we're after laying out 4 switches here. We've got our switch 1, 2, 3 and 4. So now what we want to do is we want to join all those points on the switches together in some way. So what we'll do is we'll go over here to our add wire, and we can join these together. I'll just do it as an example way. I mean, it doesn't make any logical sense at all what I'm doing here, but we'll join these together so that you get an idea of what can be done. So here we are. We've got our schematic ready. So once our schematic has been laid out, what we can do is we can hop on over to the PCB editor by clicking this button up here up top. And that brings us into our PCB editor, which is completely empty. There's nothing there. It's ready to design a PCB in. Now we can click on the Update PCB from Schematic button here on top. And what that'll do is it'll take all the symbols that we have in the schematic editor and it'll import the footprints of those into our PCB editor here. So you can see it's kind of listing what it has here. It's telling us if there's any warnings or errors, and there's none at all. So we can click on Update PCB. And what we have here now is we have a footprint for each and every one of those symbols that we laid out in our schematic editor earlier on. So the next thing really to do is to map out the limits or the form of our PCB. So I would say it's a little square 3 centimeters by 3 centimeters. So what we do here in layers is we would go down to edge cuts and we would click on our draw rectangle tool here, and we can just lay out a 30 by 30 rectangle. There we go. Well, it's 30 by almost 30. There we go, 30 by 30. And what we can do from there then is we can just move these into that rectangle so they're in our PCB. Now you'll notice as we're moving them, you'll see these kind of lines that appear. And these are what they call rat lines or rat nest lines. And what they are is they're pretty much the lines that we joined with wires there earlier in our schematic editor. And what we can do with those is we use them to lay down the traces that we want in the PCB editor. So if I go to root tracks here, I can select a track and it shows me the ones that should be joined together, and I can route that through as I so wish. Each time it'll show me where a track should go, and here for example I can't cross that track without putting in a via to go to the other side of the board, but I can go around this way here if I so wish, and I can route all my tracks together whatever way they need to be routed. So it's a handy little way of doing stuff like that. There we go. So that's more or less how you would lay out a PCB design, a real simple kind of one. And actually another tool that's very handy in this is once you have it laid out, you can check if there are any errors using this guy here, the design rules checker. So if we click on that and we click on run DRC, it'll run through and it finds here there is one error and there is one warning. So we've got one unconnected item, which is here. This pad hasn't been connected to where it needs to go. So we can connect that through to here now, and there we go. Now we should have no warnings So I run DMC and there we go. There's no warnings whatsoever. So that's pretty much how you can lay out a PCB, even though this one won't actually do anything. Do you know, it's just occurred to me editing this video that I didn't speak about KiCad plugins at all. And one of the best ones that it has is the FreeRouter plugin. Now, I would have ripped my hair out without that thing. You can lay out tracks by hand the way I've been showing you here, but there's a plugin that'll do it for you, and really it's a godsend when a board gets very complex. And what you see here is the board design with all the rat's nest lines all over the place. So instead of trying to figure that out by hand, you can install the AutoRoute plugin. So you just go to Tools, Plugins and AutoRoute and let the computer take care of all the routing for you. Now this process will take anywhere from a couple of seconds to a couple of hours depending on the complexity of the board. But once it's done, it's always a good idea to run the design rules checker. And in this case here, you see that I had 2 errors, but they weren't really any big deal. It was just that 2 of the tracks were running kind of close to some of the holes that I had put in the PCB. So all I needed to do was find where the errors occurred. They're marked clearly in the PCB editor with arrows, and just move those tracks out of harm's way. Then when you're finished kind of correcting those errors, run the DRC again, just to make sure everything is okay. And if everything is all right, you save out that board. It's pretty much after saving you about a day's work, to be honest. Here's a top tip for you. Take a photo of anything you want to copy the traces of, and using photo editing software, draw in the traces using different colors. It'll save you a lot of time and headaches. But one other handy little utility in here is that we can get a 3D view of the board that we've just designed. So here's our board here, what it'll look like when it's finished. And you can flip it around and rotate it and look at it, and you'll see the tracks and whatnot running through it. But that is pretty much that. And finally, if you want to create your Gerbers so that you can send the Gerber files for this onto PCBWay, what you would do is you would click on File and you go to Fabrication Outputs and Gerbers. And then you would input an output directory where you wanted it to go, where you wanted your Gerber files to go to. You click on Generate Drill Files and you generate drill files. And then what you would do is you would click on Plot, and that would pretty much save those out for you once you clicked on Save. And there would be your Gerbers. All you need to do is put them into a zip file so you could send them on to PCBWay. Or if you don't want to be fooling around with Gerbers, and who could blame you, you could always use the PCBWay plugin for KiCad. It'll sort out all the Gerber files for you and send them right on to PCBWay, where you can inspect the board and see that it is what you want it to be, and you can still make some changes to the PCB design. Like here, for example, I changed the board thickness to 0.6 millimeters. Then all you have to do is save your order, pay for it, and it'll be shipped to you in a couple of days. Okay, so again, before we go any further, a huge thank you to PCBWay and Zoe, who is my contact there, because this is really fantastic. These boards were turned around in no time whatsoever, and I just hope that I've designed them properly and that they'll work out properly. But anyway, let's open it up and see what's in the box here. Oh, we got a lot of packing. That's for sure. So this is looking good. These here are my PCBs. Look, they look exactly like they need be. And they sent me stencils too, for some reason. I didn't ask for stencils, but I got sent stencils as well, which is good, I guess. I don't know, or maybe they're not. I don't. That's a stencil, I think. Anyway, I've got PCBs here. That's what I've got. So we'll open them up and have a little look at them and see what they are. So just let me clarify one little thing. What I thought were stencils are in fact not stencils at all, but it's just PCBs being incredibly well packed, because these boards that I ordered are extremely thin, as you can see. They're very, very thin indeed. They're 0.6 millimeter boards, and I've ordered them that way because really I wanted them to be kind of the thickness of the mylar. Now the mylar I think was 0.3 mil or something, so this is pretty much as thin as I could get and still have it some way stable. Now look at the little thing that I tried to do here. Now I don't know if this is going to work out or not, but you'll notice that, you see, there's going to be wire going from here into a connector that plugs into the actual Thomson's connectors. So I decided to try and integrate the little connectors into this PCB to make it just one board instead of having like a separate connectory thing. And well, I tried to be clever with them. I don't know if it's going to work out or not for me, but these will break out and they'll allow us to join wires from here into the connectors themselves, and hopefully it should work out fairly well for me. But anyway, that's a kind of a look at the board. You can see the traces and whatnot right the way through, but I'm quite happy with it. You'll see up here we've got 2004 version 1 by 8 bits in the basement. And this is our Thomson MO5 mylar replacement. And I've also labeled each and every key on it. And it was just really, it's stuff that didn't need to be done, but I just wanted to see if I could in the PCB design process. So there you go. And then I stuck down this little fella here, designed with KiCad, and everything seems to have worked out great. I mean, I really know, to be honest, I am over the moon with this particular thing, but we'll just see, does it fit into the actual Thomson plastic? And we'll check that out right now. Okay, well, here goes nothing. I can't believe it. Look at this. Look at this. It fits exactly as it should in there. That is bloody amazing. Okay, so the next thing really I want to check, because that looks pretty good there. The next thing I want to check is I want to remove this rubber keyboard kind of gently, because it's a little bit damaged to itself. And what I want to do is I just want to check, look man, all of these fit in the way they should. I want to check that all of the keys, look at that, they're all where they should be. But to be honest with you, there was one little thing that I tried to do when I was laying out this design myself to begin with, and that was that I actually used the feature in KiCad where we can print one-to-one scale of the actual board that we design, you know, of the PCB design. So that's pretty much it here. So it should correspond to this more or less. And what I did was I cut out the holes and whatnot just to see that they all kind of fit in the way they should. And I was happy enough with the way they were too. So I suppose it's a way that you can check your design to see that it fits in. But man, I am so impressed with that. And I mean, I'm just rambling on now. But what I'm going to do is I'm going to run it through a few little tests with my multimeter to see that things connect up the way they should. And what I'm going to do is I'm going to go building up this board. We'll have a little look at the board build. Okay, so we'll get to that pretty soon. Okay, so I'm after building a board. It's ready to go, and we'll test it out there in just a moment together. But just to speak of the way this thing is put together and how to build it, really there are only two main things you need for it, and that is a load of key switches and also a little bit of ribbon cable. So what I've done is I've designed this to work with little Alps key switches, and what I got were kind of cheap copy ones, I think. But they're 5mm by 5mm, and they're about 1 millimeter high, and they've got 4 little legs on them that'll solder to the pads on the PCB. So what I do is I just touch a little bit of solder onto one of those pads, and then I heat it, and I just slide the key switch into position with my finger, and once it's in place and I'm happy with it, I solder up the other 3 remaining pads, and that's pretty much how I placed all of those. Now when it came to this ribbon cable, this is just regular ribbon cable, and I bought 10 strand cable, but I only actually needed 8 strands. So what I did was I cut 2 lengths of this, and then I kind of separated the wire at either end and stripped them. Now, unfortunately, this isn't solid core wire, it's the stranded stuff. So I had to twist them together and feed them through the holes on the PCB itself and solder it in place. And once I had that done, I removed the two connectors that I integrated into this PCB here. They're easy enough to remove because they're only kind of held in place very lightly. So I just cut the three bottom little tabs that were holding them in, and then they would twist out. And just being careful that they were oriented the right way, because actually with those connectors, I kind of designed them a little bit, well, I should have put the fingers on both sides. I only put the fingers on one side. And basically, you need to be careful the way you join it to the cable now so that it'll plug into the MO5 properly. But that's pretty much it. The board right here is now finished and it's ready to go. So what I'd like to do is connect it into the MO5. Well, we'll kind of put it into the plastics first and see if it works or not. So it's time to see if all the effort is paid off or not. I'm going to remove the mylar from the MO5 here, and we'll see if our newly built up board fits in the way it should. Well, we kind of know it will a bit anyway. So there's one or two little bits of pressure here now because of the way it's been soldered, but that's okay. I'll screw this in and we'll see if it works. Now, so the old mylar is now gone and we've got this new PCB in place. It sticks out ever so slightly on the bottom here, but that's okay. Do you hear that? You know for sure when you've pressed a key, that's for sure. Something funny going on up top. Okay, so all of these are now clicking correctly. It seems that if it's screwed in a little bit too tightly, you know, full screw down, it actually locks buttons. So a slight half turn back and they all seem to be working, well, clicking at least. Fine. So yeah, I guess that's because of the mylars or the PCBs slightly extra thickness. You know, it's twice what the mylar was. But okay, we'll see when we plug it in if it'll work. Okay, so this here is no kidding the first ever test. This is the first power on with the keyboard in it. We'll see if it works or not. So hopefully, fingers crossed. Hee hee hee. It's working. There is one key that isn't working, and that's this one down here, the clear key, for some reason. All of the other keys are working. Clear with basic, here it should give clear, or otherwise it should give a comma, but it's not actually working. So what I'm going to do is I'm going to open it up real quick, and I bet you that I mis-soldered that or something, or else it's just the buttons were cheap. Maybe I need to change that to get it working. I'll be back to you. So it seems these things never ever go without a hitch. I thought this was working perfectly until I got to the comma key, and that's the one and only key that isn't working. Now I tried a few different things because I figured my PCB design was infallible, but as it turns out, it wasn't. I made a big mistake. Well, not a big mistake. I made a mistake though. If you take a look at this here, this is my PCB design here for the board, and you see that switch 55, the comma switch, the bottom pads here aren't actually joined to anything. No, I kind of left floating pads. And that problem was actually introduced here at the schematic level, because you'll see switch 55, pin 2 is open. It's not going anywhere at all, which means that the comma on this board as it is can't work, but there's an easy enough solution. All I need to do is to join, I'll show you here. All I need to do is to join this pad here to this pad here, and we should be in business. So I'm going to stick in a bodge wire and we'll see if that fixes it. All right, so the bodge wire is in place right here. It's plugged into the MO5. We'll see if this has repaired it. Okay. There we go, we got our comma working. And K is also working. Yeah, so we've got all the keys working. So I'll tell you what I'm going to do. I'm going to put the whole thing together and I'll show you that little game that I was working on. Okay guys, so here we are at the end of this episode, and if you're still with me a half hour plus into the video, thanks very much. I don't know how you do it, but the reason that this video is here, which you've probably gathered, isn't because this guy is available or anything. I am going to modify the Gerbers on it so that that little wear mod isn't needed anymore, and I'll put it at your disposition if you want to make one of these guys for your MO5. But the MO5 is a rare system, so there's not going to be a huge uptake on these boards. But the reason I made the video was that I wanted to show, because it surprised me that it was not near as hard as I thought it would be to actually make a PCB design and to get it made. So if there's any out there that were toying with the idea of doing this yourselves, that's the reason this video is here, to kind of show you that it's not as hard as you might think, and have an old crack at it. And what I'd like to do just before we finish up is to once again thanks the sponsors of this video, PCBWay, for putting these boards together for me and for getting them to me so quickly as well. And finally, just to finish up, just to show you, I'd like to show you the conversion of Bob and the Alien Fireflies, which I'm sure you are all sick to death of hearing about at this stage, and I'll tell you, I'm kind of getting sick of coding it too. So the MO5 is the last system I'll be converting it over to, but I'd like to show you how far I've gotten in the coding of that, and also the bugs, because it is riddled with bugs at the moment, the bugs that I'm encountering. So that'll be coming up after this kind of goodbye, and thank you for watching, and I'll be along with another video at some stage. I don't know exactly when, but until then, take care of yourselves, and here's Bob. Okay, so for any of you who are interested, this is how far I'm after getting on my Bob conversion for the MO5. So looking at it there right now, we've got our Bob Hedgehog here moving around with the keyboard, so that's fantastic. I managed to figure out that, and that was a little bit of an exploit, but it's working now anyway. And as you can see, the Firefly is changing color, he's animated, and he's also moving around kind of, well, semi-randomly at the moment. The other thing, I've got these transporter beams sorted out. Now they're moving the way they should on the screen, the openings appearing and all the rest. Now, as it stands at the moment, it looks an awful lot like the Coco version. And that is because I just kind of lifted the sprites directly, and I just want to get the game more or less working logic-wise and whatnot. But I intend to make the sprites to look completely different, and also color-wise it'll be quite different in the Coco. Coco only had 4 colors available to you when you were doing any of this kind of stuff. This guy here has 16 colors. So hopefully I'll be able to make it look substantially different and maybe even a little better. As you can see, there's no collision detection, there's no nothing like that put in yet. I'm just kind of slowly working my way through. But there are quite a few bugs. You see, Bob, he will kind of move like this at times if you press left and right together. That shouldn't happen. Sometimes he'll move really fast to the right if you do the same thing. And the up and down buttons together kind of gives you this kind of Bob moonwalking kind of effect. Well, moonwalking he's not. But the other bug I'm having that's actually causing a little bit of hassle for me is when I go off the top of the screen, he's kind of coming back sporadically. Now, I can't really figure out what the heck is going on. There's obviously some kind of logical progression to what he's doing. But for the moment, it eludes me. But on the bottom of the screen, it's kind of worse, because he's leaving an impression of his carcass behind him to be kind of cleaned up with the transporter beams. But anyway, there you go. That's as far as I've gotten in my conversion of Bob and the Alien Fireflies across to the MO5. So I'm hoping to have it finished by Christmas. As I say, it should look substantially different than the Coco version. I'm hoping it looks even better. And it'll be entirely French language. So all of the text and all of that kind of stuff, instructions, all that kind of stuff will all be in French. And that is pretty much it for now and for this video completely. So good luck in your future PCB designs, and until the next video, whenever that may be, see ya and take care.